We're using GPU.com risers. Good stuff, real nice.
GPU.com risers.
GPUrisers.com. Hey guys, it's TekShinji here, and we got a giant machine to build today. We got 8 3090 RTX EVGA for the Win 3 cards. We got a Rebtech motherboard, which will save us a lot of space. We got 3 EVGA 1600 watt T2 titanium power supplies, and we're gonna make this all in this video. This rig is all about power density. We got 8 3090 EVGA for the Win 3s, like I said before. In one rig, we're gonna have 1 gigahash. At least that's the goal. So to achieve that, we got the most powerful mining card, well, consumer mining card you can currently get, which is the 3090. This frame right here is the Kingwin 8 GPU frame. They're currently, at the time of filming, on Amazon for $120. If you can watch in this video right here, where I actually assembled this frame and just talked about it RPM style. These are 140mm Noctua PPC fans, the industrial kind, the good kind. We got the power supplies in here kind of offset just for now. We're also going to be using GPUrisers.com, GPU risers, and I got their newest edition. This is the one with the 8 caps. 8 caps. I don't know if there's any real difference between 8 and 4, but it can't hurt. Also, this does have the butterfly clip on the PCIe bracket right here, and it's got the gold-plated USB connection. And if you guys didn't know, on a Rebtech motherboard, you don't need this fancy piece right here, which is the PCIe adapter. Take that off and just, get rid of that, and then we could plug it directly into our Rebtech just like that. And that's why we're using this motherboard. First thing we're gonna do is get the power supplies all wired correctly and get the fans connected. That way, when we put the cards in, we just literally just have to connect everything up. This should be pretty easy. I just want to talk about the wiring I got going on here. So remember, things are gonna be kind of different because we are using a Rebtech motherboard. First thing, we're not gonna need a 24-pin cable. We're not gonna need a CPU cable. This takes one PCIe 6-pin cable. Now, you might be wondering, Shinji, you're using ATX style power supplies. Why are you using that? Well, first of all, I'm in a residential setting and I do not have access to 240 volts or anything that is high voltage, unfortunately. Not right now, at least. Remember, this is gonna have an 8 3090 for the Win 3s. Each card takes 3 VGA connections. So I got these wonderful cables. These are actually PCIe 8-pin to dual 8-pin cables. These are actually custom cable mod cables. So we're gonna have one of these going to each graphics card, supplied with one EVGA stock single 8 to 8-pin cable. The single 8-pin to 8-pin cable will be going into the first slot on the graphics card because it is believed in some circles that first slot takes more power. You might be asking, how are you going to be powering the risers? So the risers, we're actually going to do something kind of special. Remember, we're not going to be using any CPU EPS cables on this for powering the motherboard or anything like that because we don't need it. This, my friends, is the CPU EPS connector. It's very similar to a 8-pin PCIe, but the pinout is very different, so do not get this mixed up. What this will do, it will plug right into this cable right here. This will go from your power supply's 8-pin EPS to a dual 8-pin, which I'm not gonna use this to power graphics cards because that's probably not safe. Instead, I'm gonna split this off into 6 pins, just like that, and use them to power the risers. You might be asking, TekShinji, how are you gonna turn the power supplies on? How are you gonna switch them? So, I got the stock power supply 24-pin cables here. This is literally like a couple of pounds, maybe 2-3 pounds of just wire. I need to come up with a solution that's a little better that doesn't use all these cables, but that's what we're gonna use. One of them is gonna use this special connector. What this does is it connects 2 power supplies together, and that makes them trigger at the same time. What we're gonna use to trigger the power supplies are these jumpers. What this does is like a power supply tester. You plug it right into the 24-pin, and what it does is it turns the power supply on. All it does is it jumps these 2 pins right here. So we're gonna use this to trigger the power supplies. That way, whenever power is added to the power supply, they'll just turn on. And the way we're gonna control that is we're gonna use a TP-Link remote switch. Wi-Fi switch, and we're just gonna turn all three of them on at the same time. Now, the fans right here, how am I gonna run all this? So what I have right here, it's connected. These are six 140 millimeter Noctua fans. They're connected to this Aqua computer splitty. This active splitty, all it does is it takes the signal and it splits it, powered by SATA. So I do have a single SATA or peripheral cable to power this. And that's gonna power all the fans, and they're probably just gonna be at 100% the whole time anyway. I'm not gonna really control that because this thing is gonna be kind of loud. It is gonna be taking 2.8 kW. We want 3 power supplies because even though Ethereum only takes 2.8 kW, which 2 is plenty for, we want this rig to be future-proofed in the sense that it can run other coins. So Raven, Firo, all those other coins. Some coins are a lot more core intensive and they take way more power. So this rig is being spec'd to take the coins that are much higher. Of course, each power supply is going to be on a separate circuit. While it's mining Ethereum, each power supply will be taking less than 1,000 watts, like around 800 or so, maybe 900 or so. And that's going to make the power supplies more efficient as well. Power supplies tend to be most efficient between 40 and 70% load. We're going to do all the wiring first, and then we're going to put the GPUs in last, because as soon as we put the GPUs in, this whole top is going to be filled with 3090s, and it's going to be really hard to get in there. This part's kind of unnecessary. A lot of people like to use the server power supplies for this, and this is one of the reasons is because you still need to use this cable to trigger the power supply, which is unfortunate, but that's the way things work. I like to use ATX power supplies because, you know, in my opinion, I like them. You know, they're better. They're usually a lot quieter than server grade power supplies, and you know, these are no laughing matter. These are 80+ titanium power supplies. These are some of the best in the industry. I mean, if we were to pay retail for all this today, we're looking at nearly over what, $1,800 of just power supply on this table right here. Literally $1,800 of power supplies. So that's all plugged in right there. Now I'm gonna wire in power for the risers. The reason why I haven't done the 24 pin yet is I wanna get all my cables laid out so I know what it looks like. So again, that's gonna go right in the center here for the EPS. It's gonna go, actually can't see it, so I gotta come all the way around. So it's gonna go in right here because remember, we're not using that in the traditional sense. So sometimes if you have a hard time getting this in, you can just do one side at a time. I was having a little bit of a hard time, and then just get it in like that. So since we got both CPU EPS being powered right here, we're not gonna power the Rebtech off of this power supply because it's already being an extra 150 watts of draw from that one, and we want it to be even as much as we possibly can. Power for the fans is right here. So what we're gonna do is take this out, put this on the far side, and then we're gonna use this end power supply to power our fans. So this is just your SATA, standard SATA connection. That's gonna go into the SATA section of the power supply, and this will be power for the fans. So now this will be power for a Rebtech motherboard. And we're just gonna put that right there. So that way we know not to use that for a graphics card. We're going to put our motherboard jumpers on. That way they will be powered independently. As soon as they receive power, they will turn on. So like I said, it's just these 24 pin jumpers. So this one's gonna get 1. So now this power supply on the end will be powered whenever it receives power. These two right here though, we're gonna do something a little different. So we're gonna plug this into here, just like that. And then we're gonna plug this 2-pin thing into here. And then we're gonna trigger both power supplies with one of these jumpers. So now both these power supplies will be triggered. So the Rebtech motherboard, again, like I said, it only takes one 6-pin PCIe right there. This white thing right there, so it only takes one. So again, we're gonna use our 6-pin to power this, just like that. Now, remember we have eight video cards, right? And we have 3 power supplies. So it's gonna be a little uneven and there's nothing we can do about that, but we're gonna try our best to maintain it. So we're gonna start off with our single VGAs. We're just gonna do 2 per power supply to begin with. Okay, so if I did everything correctly, this is all the power we're gonna need for the mining rig. So this is all PCIe power. This is just for the graphics cards, guys. The yellow ends are the only ones going to the risers. So the next thing we're gonna do now is connect up the risers. The reason why we're gonna do that is after the risers are connected, they're gonna be like on the bottom and really hard to access. This again is the 8 cap edition, and supposedly it's a little bit more stable on the power. So we're gonna go ahead and plug this in, just like that. All right guys, so we just got done wiring everything together, and as with all good computer operations, before we start adding GPUs and adding more points of failure or whatever, what we're gonna do is turn everything on and make sure the Rebtech motherboard is recognized on the network. So I did install a USB wireless adapter, and I had this set up previously, that way it's ready to go. If I did this right, what should happen is we should see a bunch of blue and red lights on the risers. The Rebtech motherboard should also have a light. The fan should turn on at full speed, and everything should be fine. Should. All right, looks like everything is running just fine. That's some good flowage. Some good flowage right there. All the lights are on. No smoke. I don't smell any smoke. Okay, so we're just gonna give this a second, let the Rebtech motherboard start up, and we're gonna see what's gonna happen here. The Rebtech is online. It is connected and it is totally fine. Everything is good. So now that we verified that the Rebtech motherboard is working and everything is connected, we're gonna go ahead and turn this off. This one. Okay, so now I'm gonna be installing this card. I'm actually gonna do this first. Click. I normally use black plastic washers for this because I found those are a little bit better because they're not conductive, first of all, and they tend to not damage the surrounding area as much. Again, we're gonna go over the fans just for now because of, you know, I'm gonna tidy this up better at another date and time. Okay, so that's plugged in. Now we're just gonna plug in the rest of the cards. All right, so we just got everything installed. We got 8 EVGA for the Win3 3090s, and the RGB is gonna be amazing on this. We're gonna go ahead and turn this on in just a second, but I'm just gonna look at this and just admire its beauty. And now we're gonna route power to it and turn this on the proper way. That's right, guys. 1 gigahash right here. 1 whole gigahash, 1 rig. This is, of course, running on HiveOS. Got 8 3090s here, and it is at 1 gigahash, we are currently pulling from the wall 2.7 kilowatts of power. We're actually connected to 3 different circuits in this house, and the 3 circuits are applying about 900 to 860 watts apiece. One of the power supplies is at 960 watts, the other one is at 890, and the other one's at 863. So it's about evenly loaded. So that gives us about 2.71 kilowatts for the whole rig. And we are currently doing 1.002 gigahash on this entire thing. So this is currently mining right now, and this room is starting to heat up quick because we got a 2.8 kilowatt heater right here in front of me. They say it was impossible. They said it couldn't, well, no one actually said any of those things, but hey, you guys can see it right here, guys. It is working. We got some awesome cards in here. EVGA for the win 3090s, and everything's working great. Let's do a quick check of thermals before we continue. All right, guys, so we have our FLIR E96 thermal camera out. You've probably seen this in some other videos. This is just gonna give us an overview of the hot spots on the rig. So we're actually gonna be looking at the rig now. We're looking at the back side of the card here, and it is pretty darn toasty. The hottest point is at around, 60 degrees Celsius. Ooh, that's hot. Now let's take a look at the inside here. This one has no heat sinks on it. Back of this one is, 70 degrees Celsius. That is just crazy hot. So looking around, you can see how the heat is coming off these rigs, off this card here. And you can see everything that's going on. It's pretty darn hot. We got this one card here on the end. This one has special VRAM sinks. And it's roughly, got some hot spots, but overall it's a little bit cooler. Now let's take a look at the Rebtech motherboard here, how we're doing down here. So we can see the Rebtech's got some hot spots on it. Ooh, that's really hot, 70 degrees Celsius. I don't know what that is, that's pretty darn hot. But actually, hold on. Nope, it's not emissivity. I thought it was emissivity. That spot is actually just really hot. Not sure what that is. So check out our power supplies. Now remember, each one of these power supplies is pulling almost 1,000 watts. And you can kind of see on the inside, it's like a little fire in there, but it's actually not as hot as you think it is. And now let's look at the power supply on the end here. Yeah, so the exact inside is around 40 degrees. Don't ignore those 70 degree numbers because that's probably way on the inside where we can't even touch. So now we're gonna take a look at the other side of the rig. So move on over here. And we're just gonna look at the top side, look at the cables to see if the cables are having any issues. Cables are in good temps. Nothing too hot on the cables. This is a good way to diagnose if one of your cables is overheating or something like that. So let's take a look at the cables over here. Now remember, I have auto scaling on the FLIR, so it's going to scale with the hottest thing in the scene. So we're now looking at the power supply side of things. Yep, all the cables seem to be decent temperatures. Remember, the cable's closest to the connection, so where the connection is, that's where it's going to be the hottest. Not the middle of the cable, but where the connection is, unless we got a weak spot. Let's take a look at our little splitty right here. This is the thing that is controlling our fans. Focus in on that. It's pretty cool. There's nothing on it. There's like a couple of hot spots, but not really. And you can see our fan. The fan hub obviously is going to be the hottest section because that's where all the heat comes from on the rotor, on the rotary rather, when it turns. But yeah, looks like everything's doing all right. No cables are getting too hot. I don't see anything that would cause any concern other than the fact that we are getting 1 freaking gigahash. This is the money shot right here, guys. This is the money shot. We're gonna make this part full screen and you guys can see all the wonderful cards just like that. Beautiful, in thermal, of course. All right, guys, so we just scanned this rig with my FLIR E96 thermal camera. We were just checking to see if there was any hot spots or if any of the cables were getting hot. It's a good way to check visually to see if anything weird's going on, but I didn't see anything of concern. So we got it here, guys. 1 rig, 1 gigahash, 2.8 kilowatts. Not the most efficient, no, but this is definitely one of the most power dense rigs I've ever seen. If you like content like this, make sure you get subscribed, hit that bell icon because we've been making way cooler stuff than this in the future. If you want to see any of the parts used in this build, we also got a link for that in the description below. Make sure you get subscribed. That's going to be it for this one. We'll see you in the next one. Take care, guys. Bye.